Namaste students. Till now we have learned about mean deviation, standard deviation and variance. Now we'll be learning about coefficient of variation. Now why is this coefficient of variation is required? Suppose we get two datas, the datas having same mean, two different series having same mean, and we have to check which series, which data is showing more variation, more variability. Then in that case we'll be in a need to calculate coefficient of variation. The formula for coefficient of variation is standard deviation divided by mean and multiplied by 100. Let us solve some examples using this formula. In this example that I have taken for you, number of workers, there are two plants A and B, two factories. Number of workers in first factory are 5,000 and second factory number of workers are 6,000. Monthly wages, average monthly salaries they are getting is same, means mean is same, and variance is given. For first company it is 81 and for second one it is 100. Variance means square of standard deviation. So standard deviation for plant A will be under root of 81, that is 9, and standard deviation for plant B it will be so since mean is same, even if we use this formula or straight away we can say the company which is having more standard deviation is showing more variability. If you use formula, then also you will be getting that coefficient of variation for plant B is more, because average salary is same but standard deviation for plant B is more. Plant B is showing more variability. Second example I have taken. Here coefficient of variations are given for two different distributions. Coefficient of variations are given, standard deviations are given, and they are saying us to calculate means for these two distributions. So first of all write down the formula. Formula of coefficient of variation is sigma upon mean x bar into 100. For first distribution, coefficient of variation is given to be 60. Sigma 1 is given 21. So putting in the formula, we will be having 60 equals to 21 upon mean is to be calculated into 100. So shifting x bar this side and 60 this side. So mean for first distribution will be 21 into 100 upon 60. So 0 and 0 got cut. 3 2s are, 3 7s are, and 2 5s. So mean for first distribution comes out to be 35. Same way for second distribution. Coefficient of variation is given to be 70. sigma in second case is given to be 16. So according to formula we will be having 70 is equal to 16 upon mean for second case into 100. Taking x to this side, 16 upon 100, 16 into 100 upon 70. So we will be having mean as 160 upon 7, means approximately 7 2s are 14, 20, 7 2s are 14, 8s are 56 and 5. So approximately 22.85 is coming out to be the mean for second case. First mean is 35 and second mean is 22.8. The next question I have taken here for a section of class 11th, mean and variance for height and weight are given to us. And they are asking out of height and weight, which one is showing more variation, more variability, the coefficient of variation. So let us calculate. For coefficient of variation we need sigma, standard deviation, and you know that standard deviation is under root of variance. So in case of height, if we calculate standard deviation, that will be under root of 127.69, and if we calculate it by long division, we will be getting our answer as 11.3 centimeter. And here mean is given to be 16.6 centimeter. So coefficient of variation will be, in case of height, it will be sigma upon mean into 100. So we will be writing coefficient of variation as 11.3 upon 162.6 into 100. And after multiplying 11.3 with 100 and dividing the answer by 162.6, coefficient of variation will come out to be 6.95. Now in case of height, first we will calculate sigma. Sigma will be under root of 23.1361. And with the help of long division, we will get our standard deviation as 4.81 kg. Now coefficient of variation using formula. In case of weight, 4.81, that is standard deviation, divided by mean. Mean is 52.36 into 100. After calculation, we will get this answer as 9.18. So coefficient of variation in case of height is coming out to be 6.95, and in case of weight it is coming out to be 9.18. What was the question? We are asking out of height and weight, which one is showing more variation? So which one is showing more variation? Weight is showing more variation.